This conference will now be recorded.
So, good evening, everyone. I think we can start because today's class is up to 6:30 only. Today we are talking about basic statistics and practical application. So I don't know whether I will be able to cover the practical things today. If I'm not able to cover it, then tomorrow we can cover it. Okay. So let me start with the basic statistics. So you are aware about most of the points. So I will cover only most important, just to give some very clear idea, and then we can go. You can switch off your mic. Very quickly, we will cover what is branches of statistics. Whose mic is on? Somebody else mic is on today. Yeah, please. Okay. So So very quickly, we'll discuss about branches of statistics, then understanding central tendencies and spread. This you already know. Then what is descriptive statistics? What is inferential statistics? Then concept of variation. So last time I asked you what is the difference between data and information. So you have answered correctly. You already got an idea about this. Data is record of actual observation. For example, marks of 35 students in a science or maths in a class. And data are useful only when we generate information from it. So data is useful only when we generate information from it. Okay. So now what is information? You know, information is answer to a question. We are actually looking for information always from a data. So for example, if you have a data of 35 students marks in science of a class, what could be the possible information you can ask from that data, or you can sort from that data? For example, please switch off mic. Whose mic is on? Shubham's mic is on. Please switch off. Yeah. Okay. What could be the possible questions we can ask with this data? For example, we can ask how many students score below 50%. This could be one information. If you have 35 students data, this could be one information. Could be I want to know how many students score below 50% marks. Then one information is maybe I need an information how many students score above 90%. What is the trend of pass percentage for last 3 years? Okay, this could be some kind of information that I am seeking for. Okay, now very interesting, all this data. Now I am going to ask one more question. What percentage of students are expected to pass in upcoming exam based on 3 years trend? Now, so far I was asking very simple information. I was seeking simple information. But just look at the last question. What percentage of students are expected to pass in upcoming exams based on the 3 years trend? So what is of my first question? How many students score below percentage, 50%? How many students score above 90%? What is the trend of pass percentage for last 3 years? Now the last question is, what percentage of students are expected to pass in upcoming exam based on 3 years trend. Okay, so my first three information are simple information. Why? Because I can generate it from the data itself. But what about the fourth question? What about the fourth question? Is it a simple question or is it a difficult question, or is it a simple information or is it a difficult information? One person can answer me.
It is forecasting, sir.
Okay. Is it a simple information I am seeking or is it difficult? What makes it different from other three information?
It is a difficult one, sir, because we are making predictions.
Prediction. So when we make prediction, what is associated with a prediction? A risk, isn't it? When I predict something, there is a risk, whether that prediction is right or not. So this makes a difference between two branches of statistics. Okay, now with this you will be very clear about the two branches. So the meaningful, what is statistics? Meaningful information from a data set can be obtained in two ways. One is describing a data set. So the best way of see, first thing is if you want to get any information from a set of data, can be two ways of getting it. One is describing a set of data. So the best simple method of describing a data is make it in an ascending order. You get a set of data, marks data, just make it ascending order. What are the three information you immediately get from the when you make it ascending order? You get what is the lowest value, you get what is the highest value, and you almost also get what is the middle value. So any data when you get, first and foremost, try to make it in an ascending way. So in ascending itself, you get three information straight away: minimum, maximum, and middle trend. Okay. So ascending a data is one way of describing it. Second, understanding the central tendency, mean, median, mode by using standard deviation and range. Then understanding the spread of data. Sorry, this is with the mean and median, and this is with the understanding the spread of the data with standard deviation. So when you are describing a data, you are describing that data with the help of what is the central tendency and what is the spread of the data. This is a very simple way of describing any data. Okay. So this is called describing them. Now, second way of getting meaningful information is drawing conclusion based on the above said description. See, very, very important. You cannot infer or draw conclusion unless you are not describing a data set. So this is very important in statistics. If you want to infer or draw conclusion, then you have to describe the data first. Then when you're describing a data, what does it mean? You are understanding the mean and the standard deviation of a data. Okay. So predicting the outcome, probability of failing percentage, testing, assumptions, hypothesis, all these methods are called drawing conclusion method. And these are the two branches of statistics called descriptive and inferential. So we will understand it, descriptive and so descriptive statistics means you are using anything you can use, like you can use a bar graph, histogram, whatever way is you describe it, but mean, median, mode, range, variance, standard deviation, anything, any ways you can use. You just describe the data. Now, what is inferential statistics? Based on the described data, you are going to predict something. Okay. So this you all already know. Mean and standard deviation, most best measure for central tendency, and variation. For variation, we can use range, standard deviation, or so. I'll not go into detail of this. You are aware of all these things. I'm only giving you the most important parts to make your concept very clear. Okay. I will not describe, I will not tell details about the mean, median, mode, standard deviation and all. I will not go into details because you are aware about that, all this. So this is one example, same example I have taken. So will not go much. You know how to calculate the mean, median, mode, everything. We can use Minitab also for calculating mean and standard deviation, but it is better to use a Excel. Finding out especially mean and standard deviation from Minitab is not easy, but it is very easy when you do a capability analysis. Everything will come in one graph. So especially you don't have to go for any mean and standard deviation in Minitab. That can be done in Excel. Now let me come to another concepts of statistics called population and sample, parameter and statistic, then concept of variation, concept of probability. So suppose I want to study, there is one company where around 30-40 people are working. I just wanted to study the behavior of these people towards, giving, when you give a task or challenge to these people, how well these people accept the task and challenge. I want to study the pattern. So what I will do, I will go to these 20 people. I can either give a questionnaire to all these 20 people, simple. So if 20-30 people are there, it's very easy for me. I can give the questionnaire to everyone and I can get a complete study. But what if I go to some other company where I have 100 people, 200 people working? Then again, maybe if we got time and resource, I may study all 100 people. Okay, but what about a company where there are around 500 people in located in one branch? Then maybe more people with located in different branches. So what is it possible that I will study the characteristics or the behavior of all the people of that company? For example, Toyota have around 10 million people, sorry, 1 million people working there, around 10 lakhs people working in Toyota. Is it possible that I give this data or survey to all 10 lakhs people of Toyota? Or Maruti, where around 5-6 people are working, Reliance around 2 lakhs people are working. If I want to study the data of complete people, is it possible? Or let us say another way, if I want to do a marketing survey of one particular place, so it's not possible that I study all those people who are under my market segment. So that time what we'll do, we need to use this population cell. So it is not possible to study 100% of group always. Now this census is coming. Every 10 years, India conducts a census. That is almost 100% study, because that is such a kind of study where we use enumerators and government plans for this. It's a huge planning. So there it's possible maybe 100% study, because that much of time, effort, money is to be put. Okay, but always it's not possible to put money, put resources to get all 100% data to be collected. Okay, so that time what we'll do, we will definitely take some samples, sample 1, sample 2, sample 3, like that. Okay, you collect different sample. So what is population? Population is group of all item under study, and then sample is a set of data drawn from a population. Okay, so for example, sample 1, sample 2, sample 3 samples. So please remember, always better to study large number of small representative samples. Remember, as a Six Sigma black belt, green belt, please remember this. It is always better to study large number of samples with a small. For example, how many people in this sample you have? 6 plus 1, 7 people, isn't it? So you can have 7 people or maybe 3 or 4 people, and you just take, it is better to take four sample size with around 25 samples. Okay, so similarly this is always good, always better to study large number of small representative samples. For example, you have 25 samples with 4 people, so total how many people you are going to study? 100 people. So similar way. Okay, Let us take another example. In a line of Coca-Cola factory, there's a line every day so many bottles have been produced. If you want to study, what you can do is you take 3-4 bottles and take around 25 such samples. In one sample, you have 3 bottles, the 4 bottles, and you take 25 samples. That means you got total 100 to study. I will tell you why we use this. There is a reason for using this, using like this. I will explain you. Maybe in this coming slide, I will explain you. So parameter and statistic, this is again a technical term. What is parameter and statistic? Why I am telling this? Because this is also very, very important. Parameter is the descriptive measures of population. So descriptive measures of population is called as parameter, and descriptive measures of uh, sample is called statistic. It's not statistics. Statistics means the complete branch of science. But when you say statistic, that means the descriptive measures of sample. So please remember this. This is very, very important, because these kind of symbols you are going to use in all Six Sigma projects. Like this is called mu. The parameter mean is called mu, and this is same as sigma. Variance is sigma square. Okay. So in the sample descriptive samples, we call x bar. When you say x bar, that means it is mean of a sample. And we call x double bar, that means mean of the samples. Sample means mean of the sample means. I will come to that later, but please understand this is x bar means mean, and for variance we use s square, and s, if you use s anywhere, that means standard deviation of a sample. Please remember this slide. This is important. I will not cover this. You know about sampling and all, different random sampling, judgment sampling, all you know. Number of units in a sample is called as, will reply. What is the answer for this?
Sample size.
Sample size.
Right.
Sample size.
Now we are coming to the inferential statistics. Now what is inferential statistics? Now understand, you have sample and I got a mean for this sample. See, x1, x bar, x bar, x bar. That means the mean of the sample one. Mean of the sample one. Now x bar and mean standard deviation of the sample one. Now we have sample 2, mean of the sample 2, and sample, right? Okay. Now for example, what is these are called? What are these? These are called descriptive measures of the samples. Okay. Now what is inferential statistics? We are going to predict based on this. We need to predict about the population. Okay. This is how, if you go do a PhD in some social science and maybe in behavior and all, these kind of predictions they used to do. Anybody is doing in PhD, but now we are focusing on Six Sigma. Doing a PhD research in with the help of statistics and doing a Six Sigma project with the help of statistics, both are totally different. Even the software is different. Like Minitab is used for Six Sigma project because it's very good tool for Six Sigma projects. But if you want to do a PhD, SPSS is better statistical software for that. Okay, but we will be focusing only on Minitab because the Minitab is the best software for Six Sigma projects. Okay, now I think you understood that. So we have this sample 1, sample 2 data. With this, we are going to find out this. Are you seeing my mouse? See what we are going to see. With the help of sample statistic, we are going to find out population parameter. Okay. With the help of this, we are going to find out what could be the population mean and sigma. Okay. But when we infer, remember there is always a risk. So for that, we are understanding how much that risk should be. What should be our risk for prediction? There comes the p-value. I'll come to that. Okay. Now comes the probability. Sample statistic, mean and standard deviation, can be used to draw conclusion about a population parameter, but conclusion cannot be 100% right. There is always a risk associated with these conclusions. This risk is referred to as probability of concluding things rightly. In a day-to convention, we may hear that probably it may rain today, and the chances of India Sri Lanka winning the tri-series are equal. And we say that probable chance, it indicate a degree of when we say probable chance oblique chance, it indicates a degree of uncertainty. Statistical methods are largely based on these probability theories. We draw conclusion about population using probability distributions. So I'm not going to going into details of probability distribution because we don't have to use it. We are like so many probability distributions like chi-square distribution, then F distribution. So F distribution is used for finding out ANOVA. So let us not go into detail about these distributions. Instead of that, we will have a very simple way of inferring things that is used by p-value. Because when you use chi-square distribution, you will have a chi-square value. When you use F distribution, you will have a F value. When you use a student's t distribution, you will have a t value. When you use normal distribution, you will have a z value. But when you can all combine all these things with the one simple thing called p value. Okay, so for Six Sigma practitioner, p value is more important. Of course, p value and f values are related. Okay, but let us not go into details of probability distribution. Let me tell you only practical aspects. So most common probability distribution can be binomial, Poisson, normal distributions, etc. Concept of variation is also, I am not going to tell you, you are aware about this. You must understand this variation. You know what are the different sources of variation: man, material, machine, mother environment, method. All these can be sources of variation. But this variation can be classified into two variation. This is also important for you as a Six Sigma practitioner. You should know what is special cause variation and a common cause variation. Special cause variation is a sporadic variation like tool breakage, machine breakdown, strike, absent, skilled employee, etc. Okay, absence of these special causes makes a process stable. Control chart is tool for identifying the special causes. Can someone tell that you are aware about these two causes were causes?
No, sir.
No.
No, sir.
Okay, this is very important for a Six Sigma practitioner. Two important types of causes. Special cause. Special cause means, for example, your pharmaceutical industry. There are big machines or mixers involved in a pharmaceutical company where you mix two components, two chemical components together, and one day what happened, that machine breakdown happened in that machine, or some other thing, like a person trained in that particular machine is absent, or there may be some fire accident in the factory. So all this, because of all this problem, what can happen? There can be a production stoppage, there can be a quality issue, like when you have a breakdown or the process is not done properly, your output specification will differ, so you will have a variation in the output. Now this variation of output is caused by which cause? A special cause, a sporadic cause? We call it sporadic. Sporadic means when you have a control chart, you will have a normal graph like this, but all of a sudden the spike goes up. Okay, that is called sporadic. So the sporadic reasons is also one reasons for variation, and there is another one called common cause variation. I don't know whether this, when I say this example, how many of you can understand this example? In old days, there used to be a Chetak scooter And anybody, your father or grandfather, anybody knows it, ask them. This scooter used to be, before starting the scooters, they have to tilt it. Without tilting, that scooter will never start. That was a reason for that. Well, you have to tilt it before starting. And nobody seen it as a problem. There is no problem, because they know if you tilt and start, it starts. So that kind of problem, there is a problem in that. No, there is a problem in that. There is a cause of variation in that, but nobody notices it. And these kind of causes are called common causes. For example, if you want to tight a nut in a machine, we know that nut is not going to tight properly. So people will do, somebody will do, put a piece of cardboard in between and keep it there. Means the problem is there, but it is not, and there is some certain remedy for people used to do that. This kind of thing is called common cause variation. Common cause variation can occur because of design fault, because of faulty design, faulty process, faulty policies, procedures. So read the last line of this slide. Aim of Six Sigma project is to remove common cause variation. Please understand the two things. What is the tool for removing special cause variation? Control charts. We are using control charts to find out common cause variation. You are using control charts in your project? Somebody can tell me, you are using control charts in your
Yes,
projects?
sir.
Yes.
Yes, sir.
Aditi, you are used to control chart in your project, isn't it? So this control chart, what for you are using this control chart? We are using this control chart to find out special cost variation, because special cost variation is find out through a, for example, a tool breakage. If you are regularly using a control chart, you will come to know that things are going above the control limits. That means something is going to happen with this process. Now you can check the tool, you can check the machines, maintain the machine, and also that it will not go to the specification limit. So control chart will be, control limit and specification limits are different. You will always find control limits are lesser than the specification limit. I will when in the control chart phase, I will explain you that most of the time people use the specification limit as a control limit. That was a big mistake they used to do. Control limits are always lesser than specification limit. Okay, so control chart is a tool to identify special cost variation, and Six Sigma is a tool to remove the common cost variation. So during the Six Sigma projects, we are trying to find out the common cost variation. So histogram I am not going to cover. Histogram, you know about histogram. I will not cover about histogram. Then now comes the most important part and most sought after distribution in Six Sigma projects. See, if you get something continuous data, no, I'll be very happy in a Six Sigma project, because continuous data has full power. I'll be always looking for wherever I can get a continuous data or discrete data. I look for that. So let us understand what is continuous data. Okay. When you put a graph, when you see, for example, histogram, you know that histogram, we will describe a data, graphically describe this data. When you make a histogram, you can see a certain pattern in the histogram. Okay, different patterns. So I will cover in this. Okay, see, when you do a histogram, you can get a shape something similar this, similar to this, similar to this, similar to this. Okay. So this, when you get histogram and you get a graph something, so the distribution something like this, it is called bell-shaped or normal curve. So we are always looking for this normal curve, because if you get a normal distribution, you can do so many things with this data. You can predict, and it will be very good for you for analysis part. So this is the shape what we are going to get if it is a normally distributed curve. Sometimes you get a right skewed also, a right skewed or left skewed. So you can get when you get shape curve in normal distribution. So normal distribution, there are two ways of two things which by using two. ठीक है. हो गया? हो गया? सबका हो गया? ठीक. So two things that we require for describing a normal distribution is mean and standard deviation. When you have mean and standard deviation, you can describe this with the normal distribution, and you can predict many things with this. Now let us compare through three different processes. Like I have process A, process B, process C. You have mean of all these process as same, but standard deviation as different. Let us see this, how it looks like. So let us see a process A. Process A mean is 50, standard deviation is 7. And process B mean is 50, but standard deviation is 4. And process C mean is 50 and standard deviation 1. So you understand what makes the difference? Process A has higher standard deviation. That means spread is more. In other words, what do we say? Variation is more in this process A. Out of this, which is the best process? If you got three processes like this, how can you say which is the best process? Can anyone?
Process C.
Yes, process C. Why? Because we have less standard deviation.
Less variation.
Now let us see what is the practical use of it. I will tell you. You are into a chemical one. You are manufacturing some pharmaceutical or maybe some drugs. Now you got three suppliers, and you just identified this mean and standard deviation. You went to their factory and you found that these are the three different suppliers. Let us not take it as process. Let us take it as suppliers. Supplier A, supplier B, supplier C. Now you have three suppliers and you got the supplier process standard deviation and mean, and you got a graphical representation. Now from here, which supplier will you select?
C.
Okay, supply C. Okay, so this is the practical use of it. So you can do it. People do it. This is how a vendor is selected, and vendor selection and vendor development management, everything is on such kind of graphs. Okay, capability analysis. When you do capability analysis, we get this. Okay, right? You can compare with this capability analysis. This is how it is compared. Now let us see different situation where you get different means and same standard deviation. How it will look like? Now, can you say which is better in these three?
No, sir.
No, we cannot say, because maybe different process, different means. So we cannot say. Even if it is same process, this is better, because why? Everybody has having standard. If you compare with my shooting example, this is something called the shooter C, where you have precision, same precision, only beams shifted. So it is very easy to shift them to the center. Okay, right. Now see, now comes the central limit theorem. Anybody know about central limit theorem? Any idea central limit? What is central limit theorem?
No, sir.
Okay, this is also important. Central limit theorem. Now, when you do Six Sigma projects, it is not necessary that you get every time you get a normal distributed data. Not necessary. You get right skewed, left skewed, double peak. Have you seen the histogram? No? So if you get a normal distribution, it is well and good. So there is a test in Six Sigma, sorry, Minitab. to test whether the data is normal or not. You know that normality test? How many have done the normality test in Minitab? Anybody did normality test in Minitab?
No, sir.
Okay. So this getting a normal data is not easy always. So what is a easy way? So there is a statistical concept called central limit theorem. Now what does it say that? See, irrespective states that irrespective of the shape of the population distribution and size of sample, the mean of the sample means will be equal to the population mean. This is called central limit theorem. What does this mean? I have data of around 100 or maybe 1,000 data of specification of a particular drug. Okay, I have around 1,000 data. When I do this, the complete histogram for all these 1,000 data, it's not necessary that I get a normal distribution. But instead of doing the actual observation, if I would have taken it as samples of data, and any data more than sample size of 25, the sample distribution of the sample means will follow a normal distribution. I will say that. I will tell you. Let me tell you like this. Okay. So what is the useful of CLT data in central limit theorem 6 sigma projects? Instead of taking individual data for any data analysis, try to take samples. That is why when you do samples, take the samples. You with the help of central limit theorem, you get a almost normal distribution. Okay, see this. See now population distribution. For example, I get a population distribution like this. Population distribution like this. Now from this is the population distribution. Okay, population distribution is always unknown until unless you are not doing the complete data and this plotting in a histogram, you will not come to know whether this population, what is the kind of population distribution. So if you have a population distribution like this, like this, like this, or like this, now I have taken two samples from this. So, and if I distribute that with the two samples, a graph, it looks like something like this. If I take two samples from this, I get something like this. If I get four samples from this, I get a distribution graph like this. Now, see the central limit of what they say, if you have more sample size, irrespective of the population size, your sample distribution will look like a normal distribution. See, this is my population distribution. But if I take samples, small samples, and I do the sampling distribution, what is sampling distribution? Distribution of the means of the samples. You get x bar 1, x bar 2, x bar 3. You remember in my this slide, previous slide, I've shown that x bar 1, x bar 2, x bar 3. Now, if I plot a distribution of x bar 1, distribution of sampling means, and if you have something more than 25, see if n is equal to 25, I get almost a normal distribution. So it is always good when you collect data, take samples rather than taking the actual values. Take samples and plot the means of samples. It will give you a normal distribution when sample size is small. Okay, we'll not go into the theory more now. So I will not go much about the normal distribution. Normal distribution is very useful distribution, very useful distribution. What is the parameter for this? Have you heard about Z value? Anybody? Z value, T value,
Yes,
Z
sir.
value. You heard about Z value now? So Z value is related to normal distribution. Okay. I'll not go much into detail. We don't have time for that. Now let me come to the process capability. This is also important. We have 15 minutes more time. Let us do the process capability. What is process capability? Before that, we have to understand through two things: control limit and specification limit. I had said in my first lecture, control limit and specification limit. It is clear to you. Specification limit is clear to you. Now, specification limit is given by the customer. Now, what is control limit and who gives control limit?
Process.
Good. Now let's come. So control limits are not given by anyone. Okay. Specification limits are given by customer. Now let us see what is process capability. Process capability is ability of a process to meet customer specification. And important tools for choosing the best out of set competing processes, predicting extent of variation in any process, evaluation of new equipment, process, supplies, whatever it may be. Process capability is a good tool to select with your suppliers. So let us examine this. Now we have, this is also I said, we have how do we get output? Through a process of inputs. Okay. So input is, now every process has its own inherent ability to produce a product or service. Now this determines your capability. Okay. So every process has its own inherent ability to produce a product service depending upon what? Depending upon what? Can you tell? Depending upon? Please give me some ideas.
Input type and process parameters.
Input, so see, input we are taking separately, but what about the process? What makes a capable process? Few things. Somebody else? What are the things involved in a process? Very simple. I'll tell you. I'll tell you. See, it is man involved in a process, machine involved in the process, material supplied. Chalo, material supplied is input. Methods used in production process. At the basic, these are the things that determines your capability. What makes a country capable? Indian suppliers, maybe the machines they use, or maybe the people involved in this. This is a big thing. You have same machine in India, Indian company of a Indian factory, and a same machine in a Japanese factory. But the people makes a difference. A person working in that person. So, but depending upon the man involved in this, and if you have a small scale factory, a small factory of pharmaceutical factory which is having just 5 crores turnover, and if you have a factory called Sun Pharma, it's more than 1,000 crore turnover. So what makes these people different? The man involved in this, the machine involved in this. Sun is more capable because they have more machines, more methods, stable methods, processes, which is not there with a small company. So every process has its own inherent ability to produce depending upon man, machine, material supplied to this process. Okay. Now this inherent ability is expressed as control limit or voice of process. It is also called VOP. Specification limit is called VOC, voice of customer. Now what are we doing this in capability analysis? Capability analysis, output requirements are specified by the customer. Okay. Now it has nothing to do with the inherent ability of the process. Okay. Now output requirement are expressed by specification limit. It is called voice of customer. Now in the capability analysis, capability of a process is ability to meet the customer specification. Okay, this is what is capability. Now how will we express this in a mathematical way? Let us go to this. So control limit, naturally any control limit is called as, it is a simple mean plus minus 3 sigma. This is the control limit for any process. So if you get mean of the process and the standard deviation of the process, you can set the control limit. You know the control limit. So what is the varying factor here to make a control limit better? What is the variable here in this? If you want to improve your control limit, the standard deviation, okay? If you want to, that means if you have more standard deviation, that means your control limits are more. Okay, if you want to reduce the control limits, your standard deviation, you need to reduce the standard deviation, and standard deviation is nothing but variation. So when you reduce the variation, your control limits are better. Understood? So control limits means, for example, you have parameter as sample 10, you get a sample 200 mn as mean and 10 as standard deviation. Then your lower control limit is mean plus minus 3 sigma, that means 170, and mean plus minus 3 plus 3 sigma, that means 230. So your control width is going to be 230 minus 70, 60 mm. Okay, specification limit is clear to you. Now, how will you find out the control limit? Sorry, capability, process capability. Now, for example, see, you have four suppliers, and supplier A is, average is this one. See, 4 suppliers you have, and all suppliers have mean as same. This is I want to select 4 supplier. I went to supplier sent, and I have studied their process, collected the data of 25 samples. I got average as mean 40, for mean as 40, supplier B mean as 40, supplier C mean as 40, supplier D mean as 30. Now how will you come to know which supplier is better? If you remember that process capability, sorry, shooting example, it was something like that. So you cannot find out with a sample mean. What you need is, you need to get sample standard deviation. With the standard deviation you get a capability analysis also. So now you tell me which standard supply will you select? Supplier A, supplier B, supplier C, or supplier D?
Supply D.
Because standard deviation less, so naturally the standard deviation less means control limits will be less. When control limit will be less, that means he will have more process capable process. Okay. Now see, lesser the standard deviation, better the process performance. So this is, now understand this, very important. What is this? This is his USL minus LSL means his specification width. Now where is his control width? See, this is the specification width of this customer. Customer has given this specification width. Okay. Now where is the control limit of for this supplier A? It is more than the specification limit, isn't it? It is crossing the specification limit. Naturally, what will happen? There will be defects. So is this a capable process?
No, sir.
No.
So when your specific control limits are lesser than specification limit, your your process is not capable. Just have a ratio of specification limit to control limit. What will have this? What will be the? Is it more than 1 or less than 1? Just see in this case, if you have a ratio of specification limit with control limit, will it be more than 1 or less than 1?
Less than
Less than
1.
one.
Less than one.
Less than 1. So I didn't tell CP, that is CP. CP is nothing but process capability. CP is nothing but specification width divided by control width. So anything less than 1, CP less than 1 means your process is not capable. Understood? Now let us understand the process B, supplier B. Now supplier B is here. Now he got both specification limit and control limit as same. Is this what will be the index? Specification width divided by control limit. What will he get if both are same?
1.
Ratio as
1.
well. So is it capable?
Sir, maybe, sir, because undetermined.
This is just capable. but we will not prefer this. Why? A small deviation, a left or right shifting will lead to raise. Understand? A small shift from the process, and process has to shift naturally. You cannot always have this process in center. When the actual condition process shifts either left or right, a small shift from left or right, what will it? It will produce defects, isn't it? So this is just capable. What is the sigma value for this? When CP is 1, what will be the sigma value? You know, what will be the sigma value when CP is equal to 1?
Probably 6.
No, this is 3 sigma. When CP is
3.
equal to 1, this is 3 sigma. This is operating in 3 sigma. Okay. Now that means any capable process means anything more than 3 sigma. Anything more than 1 CP1. CP is equal to 1. Here is C. Now see the other process. So here the specification width is control width is lesser than the specification width. So here this process is CP index will be more than 1. So CP index, when you do a capability analysis in the mini tab, just see the CP value, whether CP value is more than 1. Of course, CPK value also we have to find out. Okay, now this is called capable process. We have, so now this is the best process where it is half of the specification limit. When the control limit is half of the specification limit. Okay, when control limits are half of specification limit, what will be the CP value?
6.
2.
Half.
Very good.
0.5.
Very good. 2. So 2. When you get CP value 2, that means you are 6 sigma capable. Then the process is 6 sigma. Okay. Now let us see 4 things. Okay, 4 samples capable. CP value less than 1, process not capable. CP value capable is equal to 1, process just capable. CP value more than 1, process capable. And this is best. Okay. Now process capability study. So now every time it's not possible that you can make a graph and see the things, isn't it? So then what you will do? You have an index. So how we will calculate the CP value? CP is equal to specification width by process width. Now what does that mean? USL minus LSL divided by UCL minus LCL. That means what is this? UCL minus LCL. What is this? UCL minus LCL.
Control limits.
Okay, what is UCL? Mean plus 3 sigma, isn't it? And what is LCL? Mean minus 3 sigma. Okay, that means mean plus 3 standard deviation, and then LCL means mean minus 3 standard deviations. So what will
6
you get?
sigma.
Yes,
6
6
sigma.
standard deviation, not sigma, 6 standard deviation. 6 standard deviation. Okay, so you get CP as USL minus LSL divided by 6 into standard deviation. So when you get standard deviation and you get specification limit, you get the capability. Okay. Now, if you want to find out in Excel, you can find out. But if you put all the data in a process, this one mini tab, you get the process capability. Okay. Now, but CP is not the right index always. Okay. Why? Process always shifts. So CPK is the best value for that. CPK, what CPK do is, let us understand CPK also. CPK does, instead of doing 6 standard deviations, CPK does in this way. USL minus mean divided by 3 standard deviation, comma, mean minus LSL divided by 3 standard deviation, and take minimum of this. Okay. So CPK, for example, this CPK example mean is 22, sigma standard deviation is 0.8, then upper specification is 24, lower specification, find CPK and CP. So CP is 24 minus 18 divided by 6 into 0.8, that means 1.25. Now CPK is You have USL is 24. That means 24 minus 22 divided by 3 into 0.8, comma 22 minus 18 divided by 3 into 0.8. That means you get two values, 0.83 and 1.64. So which value we should take for CPK?
0.8.
0.83.
0.83. So 0.83 is the real capability, not this one. If you see this 1.25, it seems that this is capable. But when you see CPK, it's not capable because it is shifting from the target. So CPK is the better measure. But when you do capability analysis, you get both CP value, CPK value. Now tell me, can any time CPK can be more than CP?
No.
Never. CP can never be more than CP. CPK and CP can be same. What does that mean?
It's a CPK is a range and CP is a particular value.
CPK equal to CP means process is centered, exactly centered. CPK is always lesser than CP, and CPK is the best measure for process capability, not CP. And CP is equal to CPK means process is centered. CP is equal to CPK, it means process is centered. When CP less than CP, then CPK is the process capability of the process. Okay. So with this, let me finish for today. What we can do is tomorrow, very fast. I think is it okay today's lecture?
Yes, sir.
You got
Yes,
some
sir.
new concept?
Yes, sir.
Yes,
Okay.
sir.
So tomorrow we will continue with this, and tomorrow I take with the practical examples. I will take hypothesis testing. Anybody know hypothesis testing, writing null and alternate hypothesis?
Yes, sir.
You know, you are aware about writing null and alternate hypothesis.
Yes, sir.
So what
So
is
we
a
only heard
null
about.
and okay? What is the null hypothesis that we can write for a normality test? Okay, we'll do one thing. Tomorrow we will cover all those things. Okay. So let us finish for today, and tomorrow we'll meet again 5. Please come by 5:15 for most, or 5:25 at the most, and 6:30 by 6:30 we can finish tomorrow. That's all. Thank you very much. Okay. So tomorrow
Thank
I'll
you,
cover the
sir.
practical aspects. Okay. Right. Thank you.
Thank you, sir.
Right.
Thank you, sir.